Welcome to Module 5 of our training series for designing websites in Microsoft Azure. I'm Brett Hacker and this is Ranger Dew. In this topic we're going to take a look at design websites for scalability, deploying websites, and designing websites for continuity. Our goal today is to give you access to the information that you're going to need to take the 534 exam, architecting websites in Windows Azure. So let's get started. Designing websites for scalability. When you're designing a website for scalability, you want to think about workloads. Does the app fit? Is there an elastic demand? Are there going to be distributed users and services? If it's local and definable, then maybe that's going to be overkill. Is it a partitionable workload? If data or the workload requires scaling up, then it may be non-trivial to refactor or re-architect it to support sharding data, for example. If your workload exhibits one of these aspects, it's probably a good fit. If it exhibits two or more, it's probably an excellent fit. The architectural underpinning of Azure Cloud Services is scale out. So compose for scale. Be paranoid about worst case scenarios. Relentlessly focus to identify the weak links in the architectural chain. Front end, middleware, business rules, compute cycles, programming loops. Watch for these things. The database, real-time updates, making sure you have efficient indexed queries versus transactional speed. Be paranoid about availability and design for failure. In the bad old days, in the data center, you had to worry about battery backups and redundant power supplies, RAID arrays, dual NICs, redundant network segments. That's all handled for you in the cloud. You don't have to worry about those things. The thing that you have to worry about is, do you have a good architecture that's not going to fail? Because we're going to handle the things that you used to have to worry about. You have to worry about your app working correctly. Know the system limits, and this is going to be important for the test to know the numbers. As an architect of a building needs to know about stress limits and how long a wall can be before it has to have a support beam. In technology architecture, you need to know the same kinds of things. How fast can a computer go? There's so many moving parts inherent. You need to assume that something's broken, and Azure works with that limitation. Yeah.
So, Brett, does that mean that I'm going to need to know the actual size of the VM? So for a small workload, I might need a smaller VM, and I might need to know something.
Exactly. So be sure and research the information and the links that are throughout the stack to make sure that you're up to speed on those numbers. It's important. For web app scale, talk about some best practices. Continuing here, the business continuity. Make sure that your systems and data are accessible after failure. Disaster recovery is enabled by Azure for geo-distribution of data and systems, and especially with websites. When you put a website up with a web role or with a virtual machine in IaaS, you have to worry about making sure that you've accounted for redundancy in the site. But with websites, that's done for you, so you don't have to spend as much time worrying about that within a given data center. Make sure that the data is accessible after a human error. So make sure that your database is doing backups and you have copies of the database, because if the application causes something to fail, you're going to be able to recover. But if a human causes something to fail, you're going to have to do a restore. Be aware of upgrade and fault domains within the system. Fault domains are logical groupings based on underlying hardware, like think about a physical host or a rack. And an upgrade domain, Azure manages these internally to make sure that replicated services are patched, upgraded, or reconfigured in a staggered fashion within a user-defined grouping. To support these scenarios, SLAs require multiple deployments of sites and services.
So you're saying that without these domains, or without me putting these in place, that there are no SLAs?
That's right. That's right. Well, no, for websites, if you put a single website up, it's going to 99.9% uptime.
Wow, that's pretty good.
That's right. And again, with the subscription limits, know the numbers. Here's a best practices link. Be sure to take a look and look at the details as you prepare for your exam. Languages that are supported in .NET websites, or in Azure websites, includes .NET, Java, Node, PHP, and Python. So you're not restricted to the Microsoft stack. Feel free to bring the stack that you're comfortable with and bring those into Azure websites. Take a look at that link for details on how to leverage each of these languages in a website scenario. Within Visual Studio, you can build and deploy a website, and there's a link with details. I'm not going to go through the details of that. You feel free, and you should be sure to do that. It's a step-by-step kind of module for you to go in and build your own prototype and see how this works. And it's important to do that. You'll learn it best if you do it. And then again, with deployment options, you take a look at that link as well. For designing and debugging and troubleshooting, there is Node support for debugging and troubleshooting. There is remote debugging available, and I'll take a look at that within the context of Visual Studio. And then there's a module that can be added onto a website called Kudu, and we'll take a look at that as well. It's primarily designed for Git deployments, but it's also got a nice debugging console that's available even if you're not using Git for deployment. We'll take a look at that in the demo shortly as well. So pick a platform. Ranger talked earlier a little bit about this, and I wanted to extend it a little bit. So when you're deciding where you want to deploy your websites, you've got three options: a virtual machine, cloud services, or websites. And as you can see with this graph, there's a trade-off in each one. With virtual machines, of course, you have ultimate control. You're logging into the console, you're installing software, you're deploying services. You have a lot more support for legacy applications because, again, you're controlling the entire operating system. Of course, because you're controlling the operating system, it's not going to be as easy to manage. You're going to have to manage it as if it were in your data center. That's something that you've always had to do, so you don't really get a huge benefit there because you're still going to have to be responsible for patch maintenance, patch management and maintenance and things like that. And you'll have to add on modules to handle agility and deployment, things like that as well. So
one thing I've noticed is that some of the templates that we use for virtual machines, once they become outdated, we can no longer use that virtual machine. Right, and that's another reason why IaaS and virtual machines require a little more investment in time and effort from an administrative perspective, because you're responsible for making sure that those things are kept up to date. So I guess that kind of helps your point about PaaS and the websites and whether you're using cloud services or websites. Right, with PaaS, that's the cloud service, and so you give up some of the control. You can log into the console if you want to, but every time you redeploy, that virtual machine that's part of the PaaS deployment is going to be reinstantiated. So you're going to lose. You don't have persistence with your data on the PaaS machine. So you have to build that into your architecture by using storage services or things like that. So it sounds like that if you just choose to use PaaS, while the architecture may be slightly different, one of the advantages that PaaS has is the life cycle may in fact, or the lifespan of your application may actually be longer because you're designing for these things. Exactly. You can take out of your architecture equation, do I need to worry about patch management and deployment or operating system upgrades and things like that? PaaS is going to handle that for you. So you give up some control, like I said, but you have a little more agility because it's built in the ability to deploy in an automated fashion and continuous integration. And that takes us to websites where you have technically the least amount of control, but the things you're giving up control for are things that as a developer or an architect, they're not really interesting to you anymore. Servers and internet tools are commodity services now, and we don't need to continue investing time and money in reinventing the same old wheel of deploying patches and maintaining systems. So with websites, we are doing all of that for you, and you're going to be able to focus on your architecture, focus on your application. You have the most options for agility and management and a little bit less control and not as much support for legacy apps, although as we pointed out, there is quite a bit of support for various technology stacks to be deployed within Azure websites. So, talking about scale, we can scale manually using the Microsoft Azure monitoring services. This is an API that you can build into your software and watch for spikes and things like that and automatically handle your scale within the context of your application design. But with auto scale, we have that feature now available in Azure websites, and you can literally go in and just check off, and Ranger spoke earlier in some detail about some of the different metrics that are available to be monitored for scale events, things that need to happen, things that are going to happen that would cause your site to scale up. So auto scale is a very valuable piece, and again, something else that you don't have to worry about now with websites. So we're going to go ahead and go into our demo. All right, so we'll take a look at websites in the Azure portal, and as you see here, there's an arrow next to my website. I go ahead and expand it, and we can see our deployment slots. We've currently got 3 deployment slots I'm calling it production here. It's really technically probably UAT, but there's a QA and a test, and part of this is because I've been playing, so I've got some extra deployment slots, probably more than you'll need, although it might be useful to have an integration slot. And the way this works is as you create, when you go into your site, deployment slots are actually managed in the new portal. So we'll pull up the website in the new portal. And we'll
we'll scroll down to deployment slots. There they are. And we can see them, and to add a slot, we're going to click add. And let's call this one integration. And we'll make a copy of the current prod. And that's it. It's done. It's going to take probably about 30 seconds. And it's going to show up here as get another deployment slot. At this point, you would go into each slot and set up your jobs, your continuous integration jobs, and deploy. Probably for the integration site, you'd set up continuous integration. For the others, you would have a manual deployment, because you're going to wait until you've verified integration before you want to push that to QA, and then you want to verify it, let the QA team verify that before you push it to acceptance. And finally, once it's accepted, you would swap it in with the production slot. So swooping back over here, if we take a look at one of those slots, and there's one coming up, integration, and you can see a swap down here. So I want to swap this deployment slot with this destination. So you can swap integration to QA, you can swap QA to UAT, you can swap your release candidate into production. And this would, once I click OK, this is going to be a pretty instantaneous swap, because both of these are running, they're warmed up. And at this point, all we're going to do is make some DNS changes and have it start listening for the right URL. So that's that. Let's take a look at SQL database replication. Let's go down to databases in the current portal. And you see we've got two here. We'll open this guy up, and under GeoRep, we've got our replicated instance in the east. We can add another secondary if we wanted. And so we've already got that one. Let's choose and create a new one. And you'd set it up and choose your region and everything. So that's how you would set up, and you have up to 4 replicas. I think it's 3 or 4. Let's take a look. So let's go into the Visual Studio, take a look at some of the things we can do here. This is kind of nice. We've got Visual Studio already attached to our subscription. So we go to Server Explorer, and we can see the resources that we've got deployed. And take a look at our deployment slots. Here's our production deployment slot, and if we expand that, we can actually see the files, log files, any web jobs if we've created them, we can review the log files. We can stream the log files, and we can turn that on in our output here in VS. We can watch the logs as they're loaded, and we can also attach the debugger. First, I want to go ahead and open up and show you that for debugging purposes, I've already got it open here. There's the web config. I can open that, and it brings it down from Azure, and this is the one that's deployed live into the current deployment slot. And if I wanted to, let's say I'm troubleshooting and I want to take a look at custom errors, I want to turn the custom errors off because I want to see the actual hard error that's coming through because something's not working right. I can go ahead and turn off my custom errors. And when I save, it's going to say this is going to push the change to Azure. So it's not something you want to do for production, but it's great for troubleshooting, is to go in and make tweak changes to this. Since we don't have access to an RDP console for websites, this is the next best thing. We have live access to the files as they are currently deployed in that slot. And so we would make that save. And because we changed web config, of course, the application is going to restart. And then if there were an error at this point, it would throw and we'd be able to see it. Another thing we can do with this integration with Visual Studio is we can go and attach a debugger. So we'll attach a remote debugger. And it's going to launch the browser again, tied back to that debugging session. And we have a breakpoint set on the index of our home controller, so we are able to inspect our call stack at this point. We can inspect our local variables if we've got any that need to be looked at.
So it sounds like it's very easy to not only make remote debugging work, but to be able to put it into deployment as well.
That's exactly right, and this is what's great about websites is we've got, like we talked about, we've got the automation and the cloud, the cloud system handling the infrastructure details for us, and yet we can still do practically everything that we need to do from a development and architecture and deployment standpoint to make sure that this thing's going to work the way we want it to work. So And just be aware when you are remote debugging in a slot, just like if you're remote debugging on-prem, the web server is halted. You've frozen the thread at that point, so don't expect people to be able to continue to access your website at this point. The site's going to be locked up. So if you're doing this kind of a test, it might be useful to swap a prod back to another slot and then test that slot where you don't have lots of people beating on it if you're going to do a breakpoint, because it's going to lock it up. So let's see. Kudu, I want to take a look at add-ons for your website, extensions. And this is not the slot I want to look at. Let's go back up to here. Let's open this slot and scroll down to website extensions so it finishes loading. And we have one installed extension. And it's Site Admin Tools. This is the Kudu tool. And Kudu is used typically for Git deployments, but it's also got some nice debugging tools available. Similar to what you saw in Visual Studio. This might be good if you're not using Visual Studio. And then there's some other additional information there as well. You can add other extensions, and these are just going to come up from what's available, what's been set up for access to your sites. There's a lot of different extensions that are available. Think about this kind of like using NuGet in Visual Studio. This is kind of the online Azure version of NuGet. These are things that are available to add onto your website. And by having added this to my website, I really don't have to do anything else to leverage it. I'm going to use Chrome because I'm going to take a look at some JSON. But the name of my deployment slot, followed by .scm. This system automatically created this URL for me. It's a secure URL. I have to log in and authenticate using my subscription to access this deployment slot's instance of the Kudu environment. And at this point, I can take a look at things like application settings. And this is real time. And you can see, because it's JSON, you could integrate this if you wanted to. If you wanted to build a custom dashboard or tool inside to manage your website, you've got access to this as an API. So that's just another example of some troubleshooting things. And then finally take a look at scale. Let's go back in here and scroll down to our scale tab. It'll actually be under settings, scale. And here's where we manage scale. And you can see we've got it currently set to auto scale for performance. And right now it's going to go up to 2 instances from 1 default. This is not about accessibility. This is about performance. Azure websites are already accessible with redundancy. And for metrics, currently we're looking at CPU percentage, but you have access to change that to any one of CPU percentage, memory percentage, disk queue length, HTTP queue length, data in or data out. So whatever your scenario for your application, whatever is important to you, wherever you think the stress is going to come from, that's going to slow down the instance, be sure to monitor for that and let that be your driving event to trigger an expansion of your scale. So that's all. Let's go back to the deck and continue on talking about deploying websites. So, as we just discussed, Azure Site Extensions, there was a screen we just took a look at. So be sure and pull up that link and look at the details on site extensions and what's available to you. So you asked about deployment. Let's talk about our options for deployment. You can deploy within Visual Studio. You can deploy, and so in Visual Studio, that's right-click on the solution or the project, the primary project, and say deploy. And there's a dialog that comes up. You log into Azure Services and you walk through the wizard. That's useful early in the process when you're just wanting to see if what you've built so far works. But ultimately, when you get into the SDLC, you're going to want to construct some more automation. That's where some of these other options come in. MS Build and PowerShell, obviously command line tools to allow you to construct the properties and scenarios that you want to set up for your deployment. And then the portal. The portal allows you to go in, at least with Visual Studio Online, if that's a tool that you're using, and you can create a new build, continuous integration build, and then have it automatically pushed back into your project and effectively tie your source code in TFS Online Visual Studio with your website that you've got running.
So it sounds like all the tools that Microsoft's built are well integrated.
That's right.
So for this exam, do we need to know the different packages, the different types of packages, I suppose?
Yes, and that's on the link that I just showed you.
Okay.
So, hosting plans and resource groups. This is an important topic to also be aware of for the test. Hosting plan features and capacity are selected via pricing plan choice, and these choices, these selections that you make, are shared across all the associated websites that are set up within that hosting plan. A resource group is essentially a new web application, and within a given hosting plan, websites can be allocated to a given resource set. Multiple hosting plans can also be added to a single resource group, and that's going to allow you to define an application that spans across regions, basically. Scaling. If you want to scale up, you'll just upgrade the hosting plan to a higher tier, and you can do that at any time by going in the portal and just say, choose a more expensive option, which is going to give you more resources. And all sites in that plan are going to be scaled up. If you want to scale out, you're going to go add additional instances, which is like I showed you with the auto scale or manually scale by adding additional instances to the deployment.
So if I were trying to, let's say, take a website that we already have running on premise, and I want to bring it to the cloud, it doesn't sound like I would necessarily, if I'm just trying to do a lift and shift, it doesn't necessarily sound like I would want to use websites, because there's some things that are architecting issues that really will matter, not only on cost but also on ease of deployment and that kind of thing.
You'll have to take a look at it. I mean, if your lift and shift scenario includes third-party software that you've deployed and that's not available in the websites as a plugin or anything, then you'd have to take a look at an IaaS or a PaaS solution. However, the vast majority of sites don't fit that. There are a lot of scenarios where a standard MVC or web forms application, website application could be picked up and just moved right into websites, and it would totally support it. And not just for .NET scenarios, but for also Node, PHP. There's a lot of situations where it would be a nice fit to just go straight to websites. So here's a couple of URLs. Be sure to review these when you're getting ready for this test to get details on web hosting plans and Azure resource groups. Deployment slots, we covered that pretty well in the demo. Just be sure to take a look at the URL there and look at the details on that. So for publishing, there's a link here to take a look at how to deploy sites, which is documentation on deploying sites in Azure. This includes links to options for each of several environments, so the cloud-based or on-prem source control from within an IDE. You can deploy via FTP, or you can even write custom code and deploy via REST API if you want ultimate control over your deployment scenario. Azure Continuous Delivery in Visual Studio, the second link is a step-by-step tutorial. Be sure to take a look at that as well. And then finally, documentation for comparison on the steps necessary to deploy a cloud service if you're using PaaS. So this is a great place to go and take a look and compare and contrast what your specific architectural need is when you're trying to decide if you want to use websites or PaaS or virtual machines.
So just for my own edification, what would be the best scenario for PaaS, and what would be the ideal scenario for websites?
I mean, it's basically what we talked about. If you've got a lot of custom code that needs to be deployed, if you've got third-party add-ons or libraries that are required to be accessed by your software and they can't be rolled into the deployment, then it might be a scenario where you need to deploy a PaaS solution. Being able to have more control over scalability might be an option for you, might be a reason for you to choose, because along with some of the APIs that are available to monitor performance, you could have more control over scalability. So that might be another reason why you'd want to go with PaaS.
So it sounds like PaaS is a little bit larger thing, but websites is real easy to use.
Yes, very easy to use, and fits a lot of scenarios. So finally, designing for continuity. Scale up or scale out, thinking about the cloud, it's important to just remember that it's architected for scale out. I mean, obviously you can go and increase the resources that are available within a given virtual machine or within a given resource, but ultimately when we're leveraging the cloud, we're thinking about thousands of people or millions of people coming to our site, and there are limits to how much we can or even want to scale up. It makes a lot more sense to architect explicitly for a scale out scenario and let the system do that work for us.
It also sounds like scaling down is important, because at times during the day, perhaps when no one is there at all, we're not going to want to run all those, are we?
Exactly, and that's another reason why scale up and scale down is not as efficient as scale out, because it's a lot easier to shut those VMs off than it is to say, wow, we've got to now move our entire stack over to another smaller instance of a virtual machine, which is going to be potentially more disruptive than just shutting down some instances that we don't need because of the traffic at that moment. So when you're designing this, be sure you know what is bound. Is it compute? Is it bandwidth? Is it I/O? That's an important consideration when you're putting your architecture together. So SQL replication, we also took a look at this a little bit ago. Geo-replication ensures the databases or really any Azure resource that needs high availability are deployed in geographically dispersed regions. So be sure.
Under what situation would we want to, I mean, there's other things besides geo-redundant, right? So under what situations would we want to geo-scale it, and under what situations does that not make as much sense as just doing it within a region?
There's a couple of scenarios. One is obviously disaster recovery. If I deploy, like I live in California, and the San Andreas Fault runs from Northern California to Southern California, so I want to be sure not to pick two data centers that might be impacted by the San Andreas Fault. I might want to go West Coast, and then I might want to go East Coast. Another reason is edge performance. If I've got a lot of customers in the East Coast, I'm going to want to be sure to have a data center close to them, so I'm not having to deal with the latency of going across a longer wide area network connection. So deploying in geo where my customers are is another reason for that redundancy. We talked about the SLAs for websites, 99.9%. And with 99.9%, that means you could have up to 10 minutes a week of downtime. There might be a moment of downtime when a site's inaccessible while you're pushing an update. So something else to consider is Traffic Manager and setting up multiple sites and having them all active and letting Traffic Manager route traffic. And you can use Traffic Manager for load balancing, and you can also use it in a failover scenario where you've got a hot standby with a synchronized database standing by, and when Traffic Manager senses that something's failed, it's going to fail over to the other system. And you talked about web jobs earlier. I won't get into too much of that, but that's a feature that's available in websites, and a great feature or a great advantage or value of web jobs is that you get the ability to deploy an executable or a script or something that's going to help tidy up things in the back end or whatever your job might be, but you don't have to spin up another VM for that. If you were in PaaS, you would be thinking about a worker role to run something like that, and that's going to be additional cost to spin up another role within your web solution. And with websites, that's sitting there ready for you as part of what you've already paid for with the web.
So it sounds like web jobs are an easy way to simply clean up data, or to perhaps run to get statistics or pull things out. And one thing we were talking about earlier in Module 3 was that we want to make sure that if you mark it as continuous, that you understand it'll run on every single instance.
Right.
If you mark it as scheduled, it will choose one.
Right. So there's a link, Architect for the Cloud, that's going to go into some details on SLAs and some of these types of issues. Be sure and review that link. We talked about Traffic Manager just now. Here's a diagram of one possible architectural scenario that you might choose to put in. Backup and restore. Websites supports backup and restore, and this is useful. We haven't talked about it very much, but you have an option to deploy like a CMS, like a WordPress, and to the extent that some of your content in that WordPress deployment is going to be part of the website itself and not just in the database, website backup would be a great way to hold on to that and be able to restore it.
Now, I noticed that there are some things here, such as retention. Can you tell me about what does that do, and what is the frequency?
Why don't you tell us about it, Rick?
So the nice thing about retention is that it allows you to retain that particular backup for a certain period of time. And the frequency, of course, is how often that will be backed up. So we can also schedule backups for different amounts of time. So the feature is pretty well full featured, it sounds like.
Yeah, it is good. All right, to back up and restore the database, we talked about that a little bit when we were doing the demo. Be sure and make yourself aware of all the options that are available to you. from a backup and restore perspective for database for business continuity. Speaking of business continuity, things to be aware of. If a device fails or if resources are exhausted, these are reasons why you'd need to think about having an alternate site or someplace else for your code to be running. It can be transient faults, something to be very aware of when you're architecting. This is a shared resource, and there are times where if load spikes, your application needs to be able to recover from a failure to access, say, a database resource. And so being able to put try-catch loops in your code and make sure that you're going to be able to recover and not just give up. Plan for that. Maybe in a LAN scenario, you're used to your database always just being there at 100 megs per second or a gigabit, and you don't code for those kind of things. But in the cloud scenario, be sure to code for the possibility that the LAN may go up and down, or the database may stop responding momentarily while it's dealing with surge or load, or while it's scaling out itself automatically in the background. There may be moments where things are not available, and so you need to architect that into the solution to make sure that you retry and don't just give up, because whatever you're looking for, database, storage, whatever, it's going to be there again in a second. So just give your app a chance to go try again before you throw up your hands and let the user see an error.
Testing is real important in the cloud scenarios.
It is. So when you're architecting the data tier, idempotency is critical, and to understand what that means, it's important to know that there's a chance, especially when you're working with queues, that an operation, the same operation may happen twice, and architect for that so that you don't have something happen twice that is additive or that changes the data. For example, think about if I say delete from table where record ID equals 6. The first time I call that, the database says, here's a record with ID 6. And it deletes it. If I were to happen to call delete where record ID equals 6 again, nothing really would happen. It wouldn't hurt anything. It would just come back and say, done. There's nothing to delete, but we didn't hurt anything. Nothing really changed. By the same token, if I have a file and I copy it to storage and then inadvertently copy the same file again, nothing is really harmed unless the file changed during that time. If it's the same exact file and it just happened to get copied twice, that's an idempotent system. If you've got a transaction like a purchase, that's not. You're going to have to account for that somehow in your code and make sure that in the off chance that a transaction got submitted twice, the code doesn't inadvertently charge the customer twice. So that's something that, again, that has to be built into the code. And be aware when you're working with cloud services where it's necessary to really be aware of that, especially when you're tying all these different pieces together. Transparency windows with queues are important to be aware of for the test, and that's just a situation where when you're calling a queue, the moment, if you've got multiple instances and the next one reaches out and grabs the next record in the queue, for a window of that queue record will not be available to another machine that might then wake up and say, I'm ready to work on the queue again. If the machine that's got the queue record is not finished with it, it needs to go back and tickle that queue record every so often until he's done working on it so it stays transparent, refresh the transparency window. Otherwise, another worker role or another web job might go hit the queue and pick up and both work on them at the same time. So beware of coding for that. And then finally, anticipate failure. This is kind of a mantra for anything when we're architecting for the cloud. Don't assume that things are just going to be there. And that's true of any cloud solution because it's the nature of what we're trying to accomplish, that we're architecting for scale, and that means there's a lot of machines involved, and the more machines are involved, the greater a chance one of them is going to go down from time to time. The Azure platform accounts for that, but there's always a moment where things get shuffled around and are brought back up, and so your architecture has to take that into account. Take a look at that SQL continuity link, and it's got some good information for your test as well. So I hope we've got something out of this. Be sure to review the links and download the deck, and good luck on the exam.
Good luck.